How much water should be added to a 100.0 milliliter sample of 6.000 molar NaOH in order to dilute the solution to 3.000 molar? A. 100.0 milliliters. B. 200.0 milliliters. C. Enough to bring the total volume to 200.0 milliliters. Or D. Enough to bring the total volume to 300.0 milliliters. Let's start with the defining equation for the molarity. Molarity equals moles over volume, which we can rearrange to solve for the number of moles. The number of moles in equals molarity times volume. From this, we can derive a formula that we can use for any problem dealing with dilution. Remember that in dilution, the amount of solute remains unchanged. The only thing we are doing is adding more solvent. Therefore, the number of moles of solute before dilution must be equal to the number of moles of solute after dilution. So, molarity times volume of the original solution is equal to molarity times the volume of the final solution. The original solution is called a stock solution. It is common practice in the laboratory to keep concentrated solutions in stock and just dilute a sample of the stock to get less concentrated solutions. If we use solution 1 to be the stock and solution 2 to be the final solution, we can say that during a dilution, M1 times V1 equals M2 times V2. The dilution formula will allow us to solve for the volume of the final solution. V2 equals M1 times V1 divided by the final molarity M2. Our stock molarity is given in the problem as 6.00 moles per liter. The volume of stock that is used is given in the problem as 100.0 milliliters, and the molarity of the resulting solution is given as 3.000 moles per liter. Carrying out the indicated calculations, the molarity unit cancels out, and we get a final answer of 200.0 milliliters. Therefore, the correct answer is choice C. We add enough water to bring the total volume to 200 milliliters. You may be wondering why we did not change our volume unit from milliliter to liter. If we did, the answer we would get would be in liters, and then we'll have to convert it back to liters again, since the volumes in all the answer choices are given in milliliters. You may also be wondering what's wrong with choice A. If you have 100 milliliters of solution and you add 100 milliliters of water, won't you get 200 milliliters of solution? The answer is, in this case, probably not. In general, when we mix liquids, volumes will add up exactly only if the liquids are identical. Here we are mixing an aqueous solution with water. Volumes will not necessarily add up. You should note, however, that when dealing with very dilute aqueous solutions, it would be safe to assume that the volumes would add up. In the case we have here, our stock solution, 6.000 molar of sodium hydroxide, is not quite what we would consider as very dilute.